At the beginning of the 20th century, there was a machine that promised something radical. Not faster communication, not better efficiency, but abundance. Its creator was Nikola Tesla, and he believed electricity did not belong in wires. Tesla imagined a world where power moved through the earth itself, where energy traveled without cables, without poles, without ownership. In 1901, that idea became physical. On Long Island, Tesla began construction on what would later be called the Wardenclyffe Tower. What most people saw was a structure rising above the trees, steel, wood, a massive metal dome. What they did not see was what lay beneath it. Deep underground, Tesla installed iron shafts and copper grounding systems. The tower was never meant to broadcast outward. It was meant to connect downward, into the earth itself. Tesla believed the planet was already an electrical system. His machine was not designed to create power, only to activate it. At the time, this idea was not dismissed as fantasy. It was funded. The project was backed by J.P. Morgan, one of the most powerful financial figures in the world. Morgan believed Wardenclyffe would become a global wireless communication hub, a competitor to radio, a business. But Tesla's vision did not stop at communication. He intended to transmit power, and that is where the project began to fail. Wireless energy had no meter, no billing system, no clear way to control who received it or how much. For Morgan, that was not innovation. It was a problem. Funding stopped. Construction slowed. And by 1906, the tower stood unfinished. A structure designed to power the world was reduced to an expense. In 1917, Wardenclyffe was dismantled, sold for scrap, its underground systems buried and forgotten. What remained was paperwork. And a question. Was Wardenclyffe abandoned because it didn't work? Or because it worked in a way the world could not profit from? This is the quiet file of a machine that could have changed everything, and didn't. After Wardenclyffe was abandoned, Nikola Tesla did not stop working. But his position in the world changed. Funding became harder to secure, support thinned, and the tone surrounding his ideas shifted quietly. Tesla continued to speak about wireless power, about drawing energy from the earth, about systems that did not rely on centralized control. But these ideas were no longer treated as the future. They were treated as impractical, unprofitable, and increasingly as a liability. Tesla began filing patents that were difficult to categorize. Concepts involving resonance, vibration, transmission through natural mediums. Many of these designs were never built. Others were described but not fully explained. Tesla himself spoke carefully, often vaguely, as if the ideas were easier to demonstrate than to document. During this period, government interest in technology was accelerating. Wireless communication, energy transmission, remote signaling. These were no longer curiosities. They were strategic. Tesla's later work was followed, not celebrated, but observed. When Tesla died in 1943, his room was sealed. His papers were seized by the Office of Alien Property. This is documented. The government reviewed his notes, diagrams, drafts, unfinished ideas. Some materials were later returned to his family, others were not. Official statements claimed the papers contained nothing of immediate value, but no complete public inventory was ever released. This does not prove suppression. It establishes control over information, over interpretation, over what entered the public record. Tesla died largely forgotten. His name faded as the modern electrical grid expanded, wired, metered, owned. The world moved forward without his vision, or so it seemed. Because ideas do not disappear when they are abandoned, they wait. In the next section, we examine where Tesla's ideas resurfaced, who revisited them, and why they continue to unsettle modern systems. Long after Tesla was gone, his ideas did not disappear. They resurfaced quietly, not in public demonstrations and not in press releases, but inside laboratories, patents, and classified research. Wireless transmission did not vanish. It changed form. Radar, remote sensing, directed energy. Technologies that moved power and information through space without physical connections. The language was different. The intent was narrower, but the principle remained. Energy does not require wires. Governments understood this, especially during the 20th century, when control of energy meant control of communication, navigation, and defense. Research continued behind closed doors. Funding flowed where public investment did not. Ideas that were once called impractical became strategically sensitive. Tesla's name appeared occasionally in patents, in footnotes, in acknowledgments, not as a roadmap, but as a foundation. The modern world adopted pieces of Tesla's vision without adopting the whole. Wireless communication flourished. Wireless power did not, at least not publicly. This raises a quieter question. Was Tesla wrong? Or was his vision simply incompatible with a world built on ownership, measurement, and control? History often celebrates inventors for what they create. It rarely asks why certain ideas are never allowed to mature. Wardenclyffe failed publicly, but its principles survived. Scattered, repurposed, contained. In the final section, we step back from machines and technology and ask a broader question. What happens when an idea threatens the systems that govern the world? This is where the story becomes less about Tesla and more about the pattern. Because Wardenclyffe was not the last idea to challenge the way power is distributed. Throughout history, innovations that remove control have a short lifespan. Systems adapt, markets respond, and ideas that cannot be owned, metered, or restricted are quietly redirected. Tesla believed technology should liberate, but the modern world was built on dependency, on grids, on infrastructure, on systems that require permission to access. This does not require conspiracy. It requires incentive. Wireless power challenged more than physics. It challenged ownership. And ownership, once established, does not dissolve easily. Tesla died believing the world was not ready. History suggests he may have been right. Not because the technology failed, but because the implications were too disruptive. Today, wireless power exists in fragments, charging pads, experimental transmission, limited range, carefully controlled, enough to be useful, not enough to be free. The question Wardenclyffe leaves us with is not whether Tesla was right. It is whether a world built on control can ever fully adopt an idea that removes it. Some ideas change the world, others reveal it. Wardenclyffe did both. This file remains open until the next quiet file. T. Henry Moray's story is often summarized in a sentence: a man, a device, and a claim of free energy. But that summary removes the details that matter. Moray was not operating in isolation. He conducted demonstrations over several decades, beginning in the 1920s and continuing into the 1930s. These demonstrations were witnessed, not by enthusiasts, but by engineers, scientists, and technical professionals who signed sworn affidavits. Those affidavits still exist. They describe a device capable of producing continuous electrical output without a visible power source. Lights were powered, heating elements, motors, and not briefly, not as a burst, but steadily over extended periods of time. Moray insisted the device did not violate conservation of energy. He claimed it accessed ambient energy already present in the environment, radiant energy as he described it, a term loosely used at the time to describe energy not yet fully classified within electrical theory. Moray's device was said to rely on specially prepared semiconductor materials, crystalline compounds, rare minerals, materials he treated using processes he refused to fully disclose. This secrecy became a turning point. Without full schematics, the scientific community could not replicate his results. Without replication, validation stalled. and without validation, support evaporated. Moray attempted to secure patents. He filed some, others were rejected. In several cases, examiners stated the device violated known physical laws. Moray disputed this, arguing the laws were incomplete. This placed him in a familiar position, too technical for dismissal, too unconventional for acceptance. Then came the incident that would define his legacy. Moray claimed his laboratory was forcibly entered. Sensitive components were smashed, crystals destroyed, instrumentation damaged beyond repair. Afterward, the device never worked again. There is no independent verification of who carried out the destruction, no police report that resolved the event. Only Moray's testimony and those who had seen the device function before it was damaged. This is where the story divides. One interpretation is simple. Moray was mistaken. His device relied on hidden batteries, stored charge, or misinterpretation. That explanation is possible. Another interpretation is more uncomfortable, that Moray had discovered a method that did not align with the economic systems of energy distribution. That does not require conspiracy, only incentive. An invention that cannot be controlled cannot be deployed, and one that cannot be monetized will not be protected. What remains today is not a working device. It is a record, witnesses, affidavits, and a pattern that mirrors Wardenclyffe, an idea demonstrated, observed, and then removed from the future. Whether Moray was right is still debated. What is harder to dismiss is that his work was never allowed to fully mature, and that is a familiar outcome. Nearly 2,000 years before Tesla, long before Moray, there was another moment where power appeared to come from nowhere. The name attached to it is almost never discussed outside of textbooks. Hero of Alexandria. Hero lived in Roman Egypt during the 1st century. He was a mathematician, an engineer, and a designer of machines that behaved in ways people did not understand. One of those machines was called the aeolipile. It is often described as the first steam engine. A hollow sphere, mounted on pivots, jets on its sides. When heated, steam escaped through the jets and the sphere began to rotate. Motion without muscle, without animals, without wind. To modernize, this looks like a novelty, a demonstration, but in its time, it represented something radical. Mechanical work produced automatically, energy converted into motion without labor. Hero did not stop there. He described doors that opened themselves when fires were lit on altars, statues that poured wine when coins were dropped, hidden systems of pressure, vacuum, and counterweights. To those who witnessed them, these machines appeared to possess power of their own. The important detail is not that Hero invented toys. It is that the principles were understood and then abandoned. The aeolipile could have been scaled. Steam could have driven mills, pumps, transport. But it wasn't. The reason was not technical, it was economic. Rome did not lack energy, it had slaves. Human labor was cheaper than innovation. An automated machine offered no advantage to a system built on control. So the idea was recorded, documented, and shelved. Not because it failed, but because it did not fit. Hero's work survived only in manuscripts, copied, translated, preserved. Until centuries later when the same principles re-emerged and changed the world. This pattern repeats. An idea appears. It works, and it is set aside until the world is ready for it, or until control can be re-established. When these stories are told separately, they feel like curiosities. A tower that failed, a device that vanished, a machine built 2,000 years too early. But when they are placed side by side, a pattern begins to emerge. Hero of Alexandria proved that power could move without labor. Rome understood it and chose not to use it. Nikola Tesla believed energy should move without ownership. The technology existed, the funding did not last. T. Henry Moray demonstrated a device that appeared to draw power from the environment itself. Witnesses signed affidavits. Then the device disappeared. None of these stories require conspiracy. They require context. Each invention challenged more than engineering limits. They challenged who controls energy, who profits from it, and who decides when the world is ready. In every case, the ideas worked well enough to be documented, observed, and then quietly set aside. Not erased, not forgotten, contained. History often celebrates invention as progress, but progress is selective. It favors ideas that fit existing systems, that can be measured, metered, owned. Ideas that remove dependency move more slowly, or not at all. The question these stories leave us with is not whether these inventors were right. It is whether the world they lived in was capable of accepting what they were offering. Some ideas change history when they appear, others wait, buried in manuscripts, filed away, or remembered only as footnotes. This is not a story about lost technology. It is a story about timing, and about what happens when innovation moves faster than the systems built to contain it. This file does not close. It remains open until the next quiet file.